Hello everybody, welcome to our lesson. Today we have a problem solving. We will solve problems on the topic the magnetic field of a straight wire. So this is the goal of the lesson. At the end of the lesson you will be able to use the equation for the magnetic field of a straight wire. Now before we start solving problems, it will be useful to recall the previous lesson. So we know that current carrying straight wire will have a circular magnetic field around, and the magnitude of that magnetic field can be found using this equation. So let's start from the first problem. What is given here? The distance from the wire, it's 5 centimeters. In meters will be 0.05, and we know the magnitude for the current, it's 5 amperes, and we're asked to find the magnetic field strength. Now this is the equation to find the magnitude of the magnetic field from the straight wire. And this is the simplest problem, because all we need is just to put the givens into the equation. Mu 0, it's constant, 4 pi 10 minus 7. Multiplied the current, it's 5 amperes, and divided by 2 pi 0.05, it's the distance. And here pi will be cancelled out, 4 and 2 we have 4, 5 over 0.05 we have 100, and b will be equal to 210 minus 10. Finally, we can write it in more convenient way. 2 multiplied to 10 minus 5. Unit is Tesla. As I said, this is the simplest problem. Now, let's go to the second problem. Here we have two long parallel wires. So the current from the first wire is I, and from the second wire is 2I. Again, let's write the given here. Current from the first wire is I, current from the second wire is 2I, and distance from the first wire to the point K, it will be 2D. And distance from the second wire to the point K will be D. What else we know? We also know that the magnetic field of the first wire at point K will be equal to B. And what do we ask it here? A. We need to find the magnetic field from the second wire at the same point, and B, we need to find, here I'll write B, we need to find net magnetic field at that point. So let's start from the A, and before we start we need to pay attention to the magnetic field lines of these wires. Using right-hand rule, we can find easily that magnetic field of the first wire at right side and the left side will be this. And at the right side, the magnetic fields of the first wire will have a magnetic fields which will enter to the page. And from the left side, we have the magnetic field which is out of the page, directed towards to us. Now what about the second wire? The magnetic field of the second wire, so pay attention that the current is opposite to the first. So the fields also must be opposite. From the right hand rule, at left side, So using this field representation, let's try to find the magnetic field of the first wire to point K, B1K, and the direction will be this at this point from the right hand rule. For the second wire, the direction of the field will be this. So basically at point K we have two opposite directions of the fields. So the net field will be whether B1K minus B2K or B2K minus B1K. And let's start from the A part. So B1K is equals to mu 0 I1 over 2 pi R1, and it will be equal to mu 0 I over 2 pi 2D. Why 2D? Because the distance from the first wire to point K is 2D, and B1K finally it will be equal to mu 0 I over 4 pi D, and this is equal to the B from the given. Now let's find the magnitude of the second wire at point K. Mu 0 I2 over 2 pi R2, and let's give the numbers for this. Mu 0 2I over 2 pi D. Why? Because the distance from the second wire to point K is D. Now finally we have mu 0 I over pi D. 2 will be cancelled out. Now B2K, let's write in more convenient way. 4 multiplied to mu 0 I over 4 pi D. Why I write like this? Because nothing has changed actually. Here 2 4s can be cancelled out and it will be equal to 1. So something multiplied to 1, it's equal to that thing. But from here it's clear that mu 0 I over 4 pi D, this expression, this is exactly the same with the B1K. It means I can substitute here and write B2K, it is 4B. So basically the magnitude of the magnetic field from the second wire at point K is 4 times bigger than the magnitude of the magnetic field from the first wire at point K. Now B part, we need to find the net magnetic field. We said that B net will be equal to whether B1K minus B2K or B2K minus B1K. So always we will substitute the smaller from the bigger one. So that's why B2K minus B1K. Net field at that point will be equal to 4B minus B, and the answer final answer for the B part is 3B. What about the direction? So net field will take the direction of the second wire because it's bigger. That's why direction of the net field will be towards us. The third problem. Again, let's write the given. We know that the distance between two wires is 1 meter and the wires have a current of 2 amperes and 4 amperes. And we're asked to find the point between these wires where the net magnetic field is equal to 0. So we must find some coordinate. It can be from the first wire or from the second wire, doesn't matter. We must find some point where net magnetic field is equal to 0. First of all, let's draw the two parallel wires, and let's assume that first wire will have a current flowing to upwards. In this case, this current will have a magnetic field from the right hand rule at right side into the page, from the left side out of the page, magnetic field. And let's think that the point where magnetic field is equal to 0 net is here. Then this will be X, this side will be equal to the X, and here it will be D minus X. Why D? D is the total distance between these two wires. If here we have X, other part will be D minus X. And this is the B1, the magnetic field from the first wire, and we have a B2, magnetic field from the second wire. So when magnetic field at this point can be equal to 0. So to be equal to 0, the subtraction of these fields must be equal to 0. It doesn't matter B1 minus B2 or B2 minus B1. Basically, they must be equal to each other. So this can be possible only when B2 has a magnetic field opposite to the first wire. From logic, we can state this, and it means that the second wire also has a direction to upward. Now let's put the numerical values. B1, it is mu0 I1 over 2 pi R1, and it is mu0 I1 over 2 pi x, and B2 is equals to mu0 I2 over 2 pi R2. and mu0 I to 2 pi d minus x. It's the distance from the second wire to that point. And these expressions must be equal to each other. Mu0 I1 must be equal to this expression, must be equal to this, mu0 I2 here the 2p and the constant mu0 can be cancelled out. Now it's time to put the numerical values. I1 it's 2 amperes, x we don't know, and I2 it's 4 amperes, d it is 1 meters, and again x we don't know. So from the cross product we have 2 minus 2x is equals to 4x, and 2 is equals to 6x. Then x is equals to 2 over 6, 1 over 3. So approximately it will be 0.33 meters. So the point where magnetic field, net magnetic field will be equal to 0 is 33 centimeters away from the first wire and 47 centimeters away from the second wire. This is approximate numbers. Now let's go to the final problem. Problem number 4. Let's write the givens as always. We know now here the red wire will be first wire, I will give the number 1, and the blue wire will be second wire. So the current which flows through the first wire, it is I, and the current which flows through the second wire, it's 2I. And distances at point A, the distance from the first wire to the point A, it is D, and distance from the second wire to point A, it's also D, and B point, the distance from the first wire to point B, it's 2D, and distance from the second wire to the point B, it is D. What we are asked to find? We need to find the ratio of the magnetic field strength at point A, net magnetic field, to the ratio of the net magnetic field at point B. We need to find the ratio. So before we start, we need to find the magnetic fields of the first wire and the second wire. So from right hand rule, right side of the wire has a magnetic field with the direction of this into the page, and left side they have a direction of the magnetic field which is directed towards us. What about the second wire? The magnetic field of the second wire downside will have, from the right hand rule, field which is into the page, and the left side has a direction of the magnetic field which is out of the page. So here, not to be confused, I represented the magnetic fields with the red and with the blue. Now let's find the fields at each point one by one. So the magnetic field of the first wire at point A will be equal to mu 0 I1 2 pi R1A. So let's put the information which is given into the equation. Mu 0 I 2 pi D. This is the magnetic field of the first wire at point A, and magnetic field of the second wire at that point. It is mu 0 I2 2 pi R2A, and mu 0 2I over 2 pi D. It will be 2 mu 0 I over, it will be mu 0 I over pi D. We can cancel 2. Now, what will be the net field at this point? So it will be whether B2A minus B1A or B1A minus B2A. So we need to compare their values. So B1A is mu 0 I over 2 pi D, and it's half of the second magnetic field, B2A. That's why B2A is bigger, and net field will be B2A minus B1A, and it will be equal to mu 0 I over pi D minus mu 0 I over 2 pi D. And the net field at point A will be mu 0 I over 2 pi D. And let's find the net field at point B. B1B. First, the field from the first wire at this point, mu 0 I1 over 2 pi R1B. And let's put the information from the givens into the equation. Mu 0 I over 2 pi multiplied to 2D. Finally, it is mu 0 I over 4 pi D. This is the field from the first wire and field from the second wire. Mu 0 I2 over 2 pi R2B, and it is mu 0 multiplied to 2I over 2 pi D. Again, the field at that point from the second wire will be mu 0 I over pi D. 2 from the numerator and denominator are cancelled. Now, it's obvious that B2B is bigger than B1B. That's why the net magnetic field at point B will be equal to B2B minus B1B. What do we have here? Will be equal to mu 0 I over pi D minus mu 0 I over 4 pi D, and it's equals to 3 mu 0 I over 4 pi D. And now we know the magnetic field, net magnetic field at point A, at point B. Now Just we need to divide this. BA, B at point B is equals to mu 0 I over 2 pi d and 3 mu 0 I over 4 pi d. And we have only numbers. All these letters will be cancelled out. And it's 1 over 4 over 3 over 4. I can find the result. It is 4 over 6 or 2 over 3. This is the result. Now guys, this is the end of the lesson. If you like our lesson, please subscribe and share.